Hi, this is Josh from Over the Shoulder Coding, and today we're walking through a mock interview with Nitesh, one of my good friends, and we're gonna show you how an interview goes and then walk through feedback like we would with a mock interview to show you how you can improve. And Nitesh actually wrote a guide on Medium that we'll go over later, talking about the different ways you can impress during an interview to really stand out among the other candidates. So Nitesh, thanks for being here today. Do you want to give a quick intro?
Sure. Yeah. Happy to be here. Happy to help students and engineers get better at interviewing. It's definitely pretty hard and it's very different from other industries. So just a quick introduction. My name is Nitesh. I work at Google right now as a software engineer, working on backend infrastructure for YouTube. Been there for about 3 years, and I've known Josh from San Francisco for about 5 years now. So yeah, ready to do this.
Cool. So the question we're due today is key value store. This is a question I've asked multiple times as an engineering manager at Opendoor to assess how a candidate thinks through a problem and its complexities. So we're going to kick it off in CoderPad. I'll put in the prompt and just bear with us. There might be some syntax issues because C++ isn't something Nitesh uses every day in plain old CoderPad style, but we'll try and get through it as seamlessly as possible. So
yeah, Google C++ is a little bit different from the typical interviewing C++, so I'll do my best.
Yeah, thanks for being a good sport. So let's start off with the prompt. Let's make a key value database. Keys are always going to be strings and values are always integers. So you can use anything under the hood, like a map, an array, a list, any other built-in data structures to represent your store. And we will be testing the correctness via commands that I'm going to share now. So we'll have 3 commands to start off with: a put, a get, and a delete command. So I'm just going to copy this over so people can see. So you can see the exact prompt and refer back to it. So the 3 commands are put, get, and delete. Put is going to take a key and a value and insert the value against the key. Get is going to accept a key as a parameter, and it should print or return the value for that key. Otherwise, it should print not found. And delete should delete the key if it exists. Does that make sense?
Yeah. Looks good so far. Just to make sure we're on the same page, so I guess the put will either insert it for the first time or make a clean replacement of the value against the key. I guess the get says should print the value of key if it exists, otherwise print not found. That seems pretty straightforward. And then deletion, just delete it from the store or from the database so that anytime you get it again, it will no longer, I guess you'll print not found in that case. So far it seems pretty straightforward. You can continue.
Yeah. Let's try it out. So I'll give you kind of a sample test case, and then we can test against that really quickly. So simple test case, we're going to put with the key AA and the value 10, and we'll call get AA, we'll call delete AA, and get AA.
Okay, got it. So it looks like with the test case, you're actually just putting in strings, right?
Yeah, so we'll call like put on this.
Oh, I see. Okay, so it's not that you're giving us a string input. It's just that the function actually is being called put with that.
Yeah, I think it's just going to be a lot simpler if we just call the methods directly rather than parse strings in C++.
Definitely.
Yeah, so this is what the params would look like for the put method, right? You'd put the key and the value, get the key and delete the key.
Okay, great. So the first line would put 10 against AA, get would print out AA, and then this delete would delete it from the store, and then the second get call would print out not found. Does that sound right?
Yeah, exactly. So your output is just going to be two strings, 10 and not found.
Okay, perfect. Yeah, that makes sense. Okay, so let's get started. So nothing is given here, right? So basically I'm providing the three functions themselves.
Yeah, so it's all up to you.
So first I'm just getting out the function declarations to make sure everything's working well on CoderPad. So we know that the keys themselves only need to be passed in by reference. The put, get, delete aren't acting on the strings themselves. They're just being put in the store. So I want to pass it in by reference. So that's what I'm doing here. And then I'll copy these over as helper or as functions as well. So let's run this to make sure there's no syntax errors or anything. Okay. Well, this is working fine, but now we need to make sure that the functions themselves can be called. So I'll try that out. Okay, great. So no syntax errors. It looks like these are being called. Just to be sure, I'll also print out the names, which we can, of course, delete later. Okay, so now our test case calls all three functions, which seem to be working just fine, and the print statements work as well. So we're off to just a good start in terms of this working well on CoderPad. Now, in terms of, I guess, a solution for this, you've stated that I can use anything built in. So this is a key value database, and we do have maps in C++. So this seems like an appropriate use case of that. If I were to use, if I were to use a map, I think it would keep the implementation pretty simple. And then basically it would be mapping the new functions here, put, get, and delete, to the related functions in the standard libraries hash map functionality. Other options here are, making my own hash map, with an array or a list or anything like that. But I think that would be too complicated. It would be a longer way of making the same thing work. So I guess, what do you think about that approach so far? Kind of just mapping this to C++'s functions.
Yeah, makes sense.
Okay, great. Okay, so one thing that I guess I noticed immediately is like these can be called many times. So we need to have a good place to actually put the data structure that we're building. Um, so is that a fair assumption that these would be called, many times? All
Yeah,
four
I
of these.
mean, called get twice, like many
Yeah.
times. Called delete.
Okay, so I think it would be good to actually make a class so that we can store the hash map and then provide these functions as well. So I will create that class. Um, So a few options here. We can have, the main method create this database to start, but it looks like if we want, the put, get, and delete to just work as is, then there's no, then the storage has to be a little bit different. So are we very strict on these input parameters, or is there some, I guess, can we change it so that it takes in a hash map, for example?
Um, yeah, whatever you think will be easier. For the parameters, I think, we don't have to sanitize or check if it's a string or an integer, but maybe as part of the main class, we can just init the data structures and work off of that.
Okay. Yeah, that would be good if we could do that. Basically, we can create this class database and have these three functions within it. So in the main method, we'd create the database and then call each of these from the actual instance of it.
So you'd
So
call
let's
like
try it.
database.put, database.get, right?
Exactly. Yeah.
Yeah.
Okay. So now I've put these in here. Well, we might not need these. So let's try this. Okay, so we're good to go. Basically, we have to put the database class definition before the main so that it can know about it. So right now I made these functions all public, but I'll make the database private. Okay, so now we have the database in here. So for the put method, all we want to do is simply add it to the database or to the hash map. So let's do that. For the get, it should just print it if it exists. So we'll have to check that. So right now for the put, it's really simple. We're just inserting in the key to the value. What typically in hash maps, it kind of knows that if it's not there, then it'll put it in, and if the value or if the key already is there, then it'll simply replace the associated value. So the put should be really simple. Of course, this is assuming the key and the value are good sanitized inputs. For the get, we'll first make sure that it's there, that the value is there. If it's not there, then we already print out not found. And then if it is there, we will just print out the value. So then lastly for the delete, I hope it should just be erased. So let me double check on that. Okay, so in our okay, so right now in our test case, we put in AA and then we get it and delete it, and then we get it again, and then it should print 10 the first time and not found the second time. Okay, so far it does that. So I think we've accomplished at least the initial test case. So I want to look to see if there's anything missing or any corner cases. So I'll add in some other things. So I'll add in a string that isn't there. Would you like me to try empty strings? I guess an empty string should be fine because it's still a string. But would you want me to try in any data that doesn't make sense, or should I just stick to, I guess, the general gist of the database?
Yeah, we don't need to test in for like other data types, just
Okay.
Standard strings and integers.
Okay, so I'll add in a replacement as well. So here we're going to print out something that's not there. We'll add something, we'll get it, delete it, get it as well, and then I'll do that again, but with the replace. So okay, so far it looks good. Since we have some time left, let me see if I can clean anything up. Yeah, I think this looks good. Is there anything else that I should add to this, or does it look all right to you as well?
No, yeah, it looks great. Pretty straightforward use. So let's move on. There's a few more parts that I wanted to get to.
Okay.
So let's add two more values. Let's add a min val and a max val function. So let me go back up here to the commands definitions and talk about what min val and max val should be. So min val is going to return the minimum value currently in the store in the database. And max val is going to return the maximum value currently in the database. So on line 8 and 9.
Okay.
Definitions.
Okay, so here usually when I see minimum or maximum value, I always think of, heaps because they're great at tracking those values. Um, and especially with the database like this, I assume that, min val and max val will be called multiple times as well. So it's not good enough to just store what the maximum is, because if it's deleted, then you don't know what the max is the next time. So a heap definitely stands out as a good data structure to do this. It has it's very efficient, I guess, for exactly this purpose. So I'll try that out.
Great. Can you talk about the runtimes of a heap?
Sure. So if you need to peak at the top value, then it's constant time. If you need to actually pop the top value, then it's log n. And insertions are also log n. So inserting everything in general, like n elements would be n log n, but each time you peak or pop, it's very cheap.
Got it. So min val and max val are still going to be O of 1 operations.
Yes, exactly. However, since you brought it up, we used to have put and delete. And I mean, put, get, and delete all used to be constant time, but now if we're adding in the cost of a heap as well, now put is going to be it's going to be log n. Get will still be constant time, but delete will also be log n as well. So is that something that we need to optimize for, or would that be good enough for?
Yeah, I don't think that we're going to do better than a heap. So just going to be log n for put and delete, but good. Okay. Sorry, right. Like nice thinking about that.
Yeah. So, okay. So in terms of syntax, I know we can use a priority queue, but in terms of min versus max, I think that'll be something I'll have to look up. So first I'll just start with the max heap and we'll go from there. And you wrote should return, but do you actually want it to return, or should this be a print, just like the get?
Yeah, let's just have it print out, just like we were doing with get.
Great. Let's start with max val. So I'm going to run this, but I think I'm going to have to import the priority queue. So let's wait till it says that. Yeah, here we go. Okay, so everything else is working with that. So now we can actually start adding things to the max heap. So now in the get, we'll simply push the, let's see, this says you wanted the maximum value. Okay, so we'll push the value here onto the max heap. And then the delete will also have that. Okay, so for deletion here, I just see in place as something that might be removing it. I'm not exactly sure though. if that's what the remove is. So let's try that out. One other thing we have to do is we actually have to get the value for the key here. So what we can do here is to place a get the key. So let's see if that works. Oh, right, so the get doesn't actually return out anything. So instead I will just do one other thing for the delete. I noticed that it should only delete k if it exists. So let me try out that test case first, actually, and see what happens here. Okay, it works just fine. I guess the erase function, if it doesn't have anything, then it doesn't do anything, so that's good. And then in terms of deletion, we have to figure out, copy this, launch again. So I could actually have, right now I'm thinking about whether we have get being a void function, but for delete, since I need to pop it from the max heap, I'm trying to think whether I'd like to have another helper function that would actually return the value, or if I should just access the database in a similar way. I think right now, for the sake of time, I'll just access it by copying over some code, and then if we have time at the end, I can clean it up and put it into a helper function if that seems to be a good idea. So first, we'll take the key here. If it's not found, then we don't have to do anything. So that'll be return. And then if it is there, then what we'll do is, actually, just do it this way. Okay, so now what the delete function is doing is, if the key actually exists in the database, then it's going to erase the key. And let's see, yeah, it's going to erase the key, but then right before it does that, it's going to delete it from the max heap. So let's do that. Let's try this out. Oh, forgot some braces. Okay, so that at least compiles. Max val returns the top, delete erases it. Get doesn't have to do anything with the heap, and then put adds it on. So let's throw a couple statements in there and see what happens. Do we want any value to be printed if there's nothing in the store for a min and max val?
Great question. What do you think you would expect a max heap or a max val method to return if you were calling it on an empty data store?
So since this is kind of, these are all print functions, I think, especially since we call not found, or we print not found for the get, I think a print statement would make sense here if it doesn't exist.
Yeah.
So I'd say print either way.
Yeah, the equivalent, if you're actually using an API or library, is it might throw an error or return a nil value or something, right?
Mm-hmm. Okay, so let's throw a few of these in there and see what happens. Okay, so first we can test to make sure that the empty case works fine. Yeah, so store is empty. Oh, forgot the endl. And then we'll check after the 10. And then we'll try it after the 20. Try it after deletion. So there are a bunch of test cases in here, but I think it'll help us find out if there are any bugs. Store is empty.
Yeah, it might be cleaner to print like max val as part of the output so you can see which method is being called.
Okay. Okay, great. And then we'll see once I delete we have the 10 here. I guess I won't delete the AA this time, and we'll see what happens if I delete the BB. Okay, so now it looks like there's a bug because after I print the max val here and then I delete it, the only thing left in the store should be the AA, which is supposed to be 10, but it's not. So that means my in place is not working as expected. So let me see how to delete. Push. I guess it's possible that the priority queue doesn't have a replace function in C++. Let me look that up. Okay, so it looks like I can actually use a set instead, which will give me the min and max values as like a min and max heap, while also allowing me to remove. Let's see. I think I know what actually is going wrong. So in a heap, unless you have access to the element that you want to delete, there's no way to actually find that element. So in this case, the delete in a heap wouldn't be log n at all, because if you delete it knowing where it is, then it's log n. But if you don't know where it is, you're gonna have to search everything for it. So that's, I guess, one problem that we see here if we just use a regular heap.
Got it. And that's fine. That's just the limitation of the data types.
Well, I mean, even in general, outside of C++, you don't know where it is, right, in a heap, because it's not a sensible way of how to find a specific element. So what I could do in this case is have a hash map from the value to the location within the data structure, but that would probably be a significant amount of code.
Got it.
So I'm trying to think of other options here.
Let's see if there's a C++ heap library that's a little bit better.
Okay. I think for right now, I could just use the set because I saw that has it. So let me just quickly change this and see what happens. Oh, wow, a lot of errors. Okay, so entering the value here. Okay, it looks like there's some errors now, so I'm just gonna comment out everything with the max heap so we can find out where the error is. Okay, so it looks like the set itself is fine. Let's see where we run into an issue.
So it looks like your max val is printing, but actually your get method is what's putting out the 10.
Okay, let's see.
Yeah, so if you
Yeah,
do
no,
anything, you
there's nothing. Yeah, that makes sense because there's nothing here that's printing out the value max val. It's just that there seems to be some like syntax issue with this not printing out the max heaps highest value. So I don't know why that's happening. Oh, begin gives it iterator. Okay, let me see. So right now, let's see, this is not giving out the max, it's giving out the min. Okay, so our begin is going to be the max, and then min val hopefully should be the min. So let's get that working first, and then we can clean it up. Okay, so I think this should be good. I'll have to go over all these test cases again. But just to kind of summarize what I've been doing, I have the set, and set in C++ will be able to give the functionality for the min and the max. Again, going back to how heaps work, since you don't know where exactly the min is, if it's a max heap or vice versa, you would have to actually find it somehow. And then after that, you would have to remove it and then rebalance the heap. So there's no great way to delete from a heap because that's not really what it's for. Heap is usually just for popping, insert, peeking. So this is like kind of stretching what a heap would be. So if we use C++'s set, it has some extra functionality. So the benefit here is that I can very easily print out the min and the max. But the drawback is I can't give guarantees on what the space or time complexity would be. I have my best guesses, like for delete, I'm sure it would have to be, well, I guess it is a set, so it could be constant time, but if they're also managing the heaps in the background, then I would guess it's closer to linear time in terms of deletion. So depending on how much we're going to be deleting versus the other operations here, put, get, min, max, val, that would probably just help me decide what the best data structure is. But if we're okay with having, linear time deletes, but having pretty inexpensive puts, which should be log n, and then of course the get, min, and max val are all constant, I think that should be good enough. But of course it depends on how we use this API.
Yeah, makes a lot of sense. So let's add one more value and one more method. Let's add one more method called value count. And value count should return the count of keys with value x. So
okay,
put that here as well.
Oh, interesting. So I thought the put would mean that there's only one key since it's a key value database. So oh, sorry, it says value x. Okay, never mind.
Yeah.
Okay, so yeah, of course, many keys can have the same value. Count the keys with value x. Okay, so there's a couple ways to do this. We can have another hash map that just keeps track of the count for each value. I don't think that would be too expensive. That would double the storage because you'd have another hash map, but that would keep the space complexity the same. And then in terms of time complexity, it would be pretty good because of it's a hash map, so you can delete, insert, and get as you wish. But let me think about it a little bit more and see how it would affect everything else. So min val, max val shouldn't really be affected by this value count operation. It looks like if we just have the other storage, we could still get this in a pretty efficient manner. What are some other ways to do this? So right now we just have the heap. I'm thinking like, if we stored something instead of an int, but kept a count, but I still don't think that's a good idea because many keys can be mapped to one value. So yeah, let's just go with the hash map solution to start, and I can see if any problems arise.
Yeah, sounds good.
So let's name this value to count, so we know exactly what it's representing. And then we'll just go one by one in each of these. So the put value to count dot, you know, oh, sorry. So first we'll check to see if this exists, and if not, then we'll insert one, and if it does exist, we'll increment it. So I'll copy some code that I have over here. And there is some repeated code here, but I could always clean that up later. But I just want to get a working solution first. Okay, let's try this out. Okay, so at first it looks good because it's printing out there's two tens, which would be the A and the B. So then we'll try it out before and after and see what happens. And then after the deletion, or after the change as well. So it should be 0 to start. Oh, let's put a del. Okay, so before we add it, it's 0, and then we add it, it's 1. Then we add the BB, so then becomes 2. Then we do value count again after it changes to 20. Okay, so it looks like the deletion didn't work, so let's figure out why. So in this deletion, if the key exists, actually, let me go through again and make sure that there is a bug. So it should be 0 to start, then we add it, so then it's 1, as it says here. Then we add another 1, so then it should be 2. Then we change the 10 to 20, so then it should just be 1 for the last value count, and it's 2. Okay, so that's not working. Oh, okay. So that I see what happens. So I made this logic in the delete. However, I did not make the logic in the put in terms of replacement. So that's why I need to add it.
Can you explain that real quick?
Yeah. So the bug is happening because over here, when I change the 10 to a 20, it should make the count of 10 go back to 1. So I put that logic in delete because that would happen if I deleted the value. However, I didn't delete BB's value. I just changed it from 20 to 10. So, or yeah, I just made a change. So that's why, or that's why I have to put in this logic for the value count database into the put function as well.
Got it.
So yeah, so now, oh, it is in the put function. So
You're
let me see this.
incrementing it in the put function.
Oh, okay, got it. So I didn't I didn't decrement it. Okay, let's see. So let's get the old value first, I guess. And again, I'm going to make this a little bit messy just so I can get it to start. Okay, so now this is saying if the database has the key, then keep track of the old value. So old value equals, this database value. And then now we want to decrement the old value. And then of course, if it's, if it's here again later, it'll increment it. So should be all right. Okay, great, that fixed it. So the 2 went back down to 1. So I could do a few more test cases, but I think what I have right now more or less gets the gist of what could be going on. I guess lastly, I'll do a deletion here and then check the value count. Yep. Looks like it works.
Great. So can you just walk me through what's going on in your put method?
Yeah. Okay, so first we have to take into account that the put can be a replacement or the initial adding of the value. So I'll add some comments here. What we do is, well, I mean, this doesn't need, this is self-explanatory. This is just making sure that the key has a value. But essentially, this keeps track of whatever the old value was, and then it decrements it. So it decrements the old value from the value to count. And then it takes in the input here, which is the new value, and it adds the new value to the heap, etc. And then it increments the new value and value to count. The reason why we have a decrement step and an increment step is in case it was a replacement, we want to make sure the old value is gone from our count and the new value is added.
Got it. So let me try out one test case. Let me comment out your test case that you've created here. And let's call, yeah, thank you. Let's call db.put a1, u.put 2, u.put a3. So what we expect from here is what?
It should be 3. Oh, oops. Oh, max val 3, min val 3. Value count of this should be 0, 0, and 1. So let me see. 0 should work, I believe. Let me see about value counts. Oh, okay. So I think it'll be 0 either way, and we can test it out and see. But one optimization I can make is removing, if we do get to 0, to just remove it from the store so that we're not adding excess storage. But let's see if that works to start. 3, 1, 0, 0, 1. Okay, so something's wrong with min val. Is that what you were looking for? Some bug with min val for this test case?
So we didn't change anything with min val, right? And min val is only getting the minimum value stored in your set. So where do you think the bug is?
Oh, I think in the replacement, I haven't taken it out of max heap, so I should do that in this max heap one. Let's see. Yeah, because right now, if you replace, you insert the new value, but you don't actually take out the old one. So that's yeah, good stuff.
Great.
Okay.
Looks good. If you had a little bit more time, how do you think you would change your code and restructure it?
Yeah, great question. So let me see where I have a bunch of things I would get rid of. One of the things I would do is I would probably just keep all these string constants in one place. So so there's no bugs or any issues with that. We can, especially if we needed to print them out multiple times in different places. For min val, max val, I think it's pretty clean in terms of just checking if it's empty and doing that stuff. I could always use some ternary operators instead of all these big if-else cases. So that would probably be a quick way to clean up a little bit of code, but it doesn't add that much to readability. So some pros and cons there. And then, okay, so one other thing I would want to do is when we do get rid of a method, or when we do get rid of a string value pair, whether that's via a delete or a put, there are a few repeated, a few things we need to do, like get rid of the value of value to count, delete it from the heap, etc., and get rid of it from the database. So I would make that into a helper function. It would just be like, element gone or something like that, value gone, because then that would take care of the logic for both put and delete.
Got it.
I could alternatively just call the delete function from put, but it just depends.
Yeah. So if the value's found, call delete and then go through the put, right? So either way, if you're overwriting or you're changing or you're just inputting the same thing again, either way, by calling delete and then adding it back in, you're not going to have any overwrite bugs like we just found.
Exactly. Yeah.
Cool. Great. Thanks for walking through this with me.
Yeah, no problem. Talk to you a little bit after so we can go over it.
Yeah, sounds good. All right. Thanks for watching the video thus far. If you liked it, give it a thumbs up for Nitesh, who did a great job on that interview. This is a little article on Medium that Nitesh wrote up talking about how to impress during a data structures and algorithms whiteboard interview from the point of view of a Google software engineer who's interviewing other candidates or how you can put your best foot forward. Nitesh, do you want to walk us through this article?
Sure. So essentially, this article is for when you've already mastered the technical skills. So it's not teaching you, which data structures to learn or like what algorithms to get good at. This is assuming you're ready for interviews in terms of being able to solve it technically. A lot of the problems that I see from interview candidates is they aren't able to explain their thought process well, or they may know exactly what they're doing and code up a good solution, but they don't communicate well that they understand like why things work. So we can go quickly through this documentation, but in the beginning, and Josh, feel free to just like scroll kind of quickly, but in the beginning, it's all about making sure you're going down the right path, getting some approval from your interviewer. And then it's talking about how you want to design your solution. You want to look at different corner cases. You want to talk about the pros and cons of different approaches. Well, Josh can go over like if I did that in our mock interview, but essentially you don't want to just pick the first thing that comes to your mind and not explain why it's the best one. So many of these problems are about time and space complexity, efficiencies, depending on how the API is used. So you want to first of all ask those questions, but then also tailor your design to the answers and for what you're optimizing for. And yeah, we can scroll down a little bit more. So this goes a little bit more into how you should write your code, compartmentalizing your code. That helps with helper functions, so you don't have to repeat code. And then there's naming functions. This shows that you care about the code base that you're building, and it also helps a lot to debug. I've seen a lot of problems where people know that there's an issue, but the variable names are so tough that they can't exactly track down what is supposed to be doing what. And it also leads to communication problems between the interviewer and interviewee if you don't have good variable names. Watch the clock is really important. This is because most interviews are timed. They might even be in a room for a specific amount of time with a hard deadline. So you want to know how much time you have left so you can speed things up. If you need to make concessions, like writing some pseudocode or something like that, you just want to know how much time you have left so you can make sure the interviewer knows exactly how capable you are.
Yeah, so, and I would say for this one too, you want to leave some time at the end so you can ask them questions about the company you're interviewing for, so you can get an idea if it's a good fit for you.
Yeah, for sure. So yeah, the last few steps are, make sure you get something down. Even if there's like extra parts for the bonus questions where you just want to, say what you would do, that's fine too. But for the main problem, get a working solution down. And then lastly, when you're going over why you chose your approach or going over your final solution, when you talk about the time and space complexity, break it down and actually explain how you got the answer. So don't just say it's linear time or quadratic or something like that. Explain why it works that way, and you can go through different parts of your problem. And yeah, lastly, if you have other ideas on how to improve your solution, but there's no time left, make sure you say them out loud so the interviewer at least knows that you were thinking about other things than you would if you had some more time.
Yeah, absolutely. And I think the last part too, explaining your code, each section is really important. for an interviewer, if you don't talk about the different trade-offs and you go on a particular solution and it happens to work, I might or might not give you the benefit of the doubt to say you knew what you were doing each step of the way versus you just got lucky and, somehow figured out to implement breadth first search on this problem, whereas, somebody else was trying to do recursion, right? If you can walk through each step, your thought process, and explain why it works, for sure I'll be saying this person thinks through things well, instead of, oh, maybe they got lucky and found the right solution. Cool. Yeah, if you guys want to take a look at this article, it's a great article. I'll leave the link in the description below. For now, though, let's jump over to the feedback portion and review the interview that we just did with Nitesh. Cool. So I'm playing back the interview that we recorded on CoderPad, and we're going to kind of jump through this pretty quickly. I took some notes on the right-hand side, and we can just walk through. The first thing that Nitesh did well was Nitesh clarified what the alpha would be before beginning. So as we're going through this problem, I dump in the prompt here, and I list out the commands that we want to do. I talk briefly about what the commands are, and Nitesh doesn't jump in and start coding immediately. He says, okay, let me take a step back and make sure I understand what each of the parameters are. And he even lays out a nice interface of put, get, delete with the parameters and their return types, just to make sure that he understands what is being asked. A lot of candidates go down the wrong path, and they just answer a problem that isn't really what's being asked of them by the interviewer. And if the interviewer's having a grumpy day, they might not even stop to correct them and say, hey, actually, we want to solve something else. They'll just let them go down this path, and they obviously have a pretty poor interview because they didn't answer the problem. Yeah, so at this point, Nitesh has gone through and actually put in the put, get, and delete functions. He's implementing them, and he's printing just to make sure that the IDE CoderPad is working properly, and can print all the different things, which is a pretty safe way to progress through this interview.
One other thing to add about making sure you understand the question. I know for this problem, there was like some confusion between returning a value or printing it. And oftentimes the interviewer may have some small mistake or may not give all the details. So if you don't double check or even catch, errors from the interviewer, then you might also go down the wrong path.
Yeah, definitely. We ran into that issue in this interview as well. Well, I think at this part you were going through the syntax, so maybe we can skip past it.
Sure.
I did want to call out one thing that you did well. So at this point, Nitesh has implemented the put, get, and delete functions, and he's also created a test case by himself to go through and validate everything to make sure that the methods are working as we expect. He's also compartmentalized his code while there's public methods that are implementing the interface of put, get, and delete. And he's also separated out his data structures as private objects in the class. So there's nice compartmentalization of code. He's proactively testing himself. We're vetting what's coming out is actually correct. And then we're moving on to the next part. So all great things that an interviewee should be doing to demonstrate that they actually understand what's going on, and they are self-testing. So usually a lot of people will say, hey, I think this is done, and there might or might not be a code. And if they don't test it out themselves, the interviewer is going to point out, hey, you have this code somewhere, or you have a bug somewhere, and it's not going to look good for the interviewee. So you want to be on top of that and be testing it out yourself just to verify that everything's working properly. Cool. So at this point, we are implementing the next set of methods, min val and max val. One tip I would give to people who are going through this in a real life situation where time is being a crunch is just to say, min val and max val, they're like symmetric. And what you can ask the interviewer is it okay if I don't implement both methods? I just implement one, because basically you're doing the same thing twice. And usually I'll say, yeah, that makes sense, because they've clearly thought through this and they understand they just be writing the same code, just reversed. So a little tip to save you some time. At this point, when Nitesh finished put, get, and delete, he also walked through and talked about the big O computational complexity for the time and space complexity, which is really great for put and delete. And then when we jump into the min val max val part of the question, he also talked about the edge case of min val max val on empty stores and what we should return if we are starting out with the database and there's nothing in there. So these are all great edge cases to consider and talk through ahead of time with your interviewer. So I think for the most part, you finished min val max val pretty easily after we brought in the set.
Mm-hmm.
Okay. Let's jump to max val, which you actually ended up just implementing max val.
Oh, did I really?
Yeah, that's fine. Cool. So the other thing Nitesh did really well here is he identified the data structure he wanted to use, which was a heap. We looked up the library methods for this, and we actually realized that the heap implementation in C++ wasn't as good, so we pivoted to using the set library. And it's totally fine to look up documentation in your interview. For me, actually, it's a sign that you understand how coding works. You're able to read documentation and implement it into your code. And once we used the set library, things became pretty straightforward. And we were able to then talk about the time complexity. So Nitesh, at this point, if you jump back into the interview, he talks about the trade-offs between a linear put, linear delete versus what we'll be doing with the heap. So we're going from O of one put and O of one delete to linear, and we're talking about how much each API is being used. Are we using max val a lot? Do we care about O of one max val versus are we using put and get and delete a lot? Because if you're only using max val once every million calls, maybe you don't care about optimizing the max val time. You care about optimizing put and delete. So what you could do is in max val, just loop over your entire database in linear time because you're only doing it once every million calls. But that's definitely a trade-off discussion, and it's good to highlight your understanding of the different trade-offs for your interviewer. After we implemented max val, Nitesh knew that it was the same thing as min val, so he just copied over the max val implementation for min val. And then we moved on to the value count, the final part of this interview. Yeah, when we first started on value count, Nitesh knew that he wanted to keep a map of key, which was the value, and then the value, which was the count of how many times that value appeared. We talked about, are there other methods? There weren't really good other methods, but it was at least nice to go through that discussion with Nitesh to validate the understanding. This is definitely an area where if you just say, hey, I'll use a hash map, a lot of people use hash maps for everything, but being able to demonstrate that you understand hash map is the best data structure for this definitely goes a long way. So Nitesh did everything great up until this point. And let's just get into one area where he slipped up a little bit. So, once we started implementing more methods, he realized there was some override and replacement issue with put and delete. And he started copying over a lot of his code from the delete method here into the put method. And he even commented himself, hey, this isn't very clean right now, but I'm just doing this to get a working solution. So, if you're doing that, that's fine. It's good to tell your interviewer, But if you're not rushing through the interview too much, you might want to take some time back to say, hey, is this really the best way to do this? I know this isn't clean. This is just a quick and dirty solution. Is there a better way to do that here? And what happened later in the interview is we ran into an issue of overwriting where, Nitesh did know to implement, to change the count, but we previously had implemented min val, max val, and he forgot to also account for that when he was handling this override bug. And so if he would have thought more about why am I copying over this code, what's actually going on in this override scenario, he would realize that what he's doing is actually deleting this key value pair and then re-adding it to the library. So he could have used his delete method, which we ended up getting to anyways, but would have saved him a little bit of headache in the debugging process. Cool. I did also make a note that Nitesh had copied over his val count solution. If we scroll back, we can see when he starts on val count, he copies over from the max heap or the min val implementation. It's okay to do this. It's a quick and dirty, but a little nit here would be, hey, I'm going to implement value count. And we all know that value count takes a parameter, which is an integer. And just to define that interface ahead of time and start clean with what you're trying to implement in mind goes a long way towards demonstrating intent and being thoughtful throughout the interview. Cool. That's almost all the feedback I had for Nitesh. I mean, you did very well in this interview. You got through 3 sections, which is, for me, kind of the bar for when I start considering people for, senior dev roles. Obviously, you have a lot of experience. You work at Google. You're a great software engineer. So I expect you to do well in this interview. What were your thoughts about the interview? Do you have any feedback or anything else you want to tell the audience?
Yeah, I mean, I think it went pretty well. I would have liked to know ahead of time that there were more questions coming up. A lot of the emphasis in my guide is to make sure you can get as much of a working solution down as possible before time runs out. Here we didn't have the typical time constraint as you would, but if you know as an interviewee that you have follow-up questions coming, you could make better decisions about time or when you decide to clean things up or how you reuse code, etc. Other than that, I think it was great that we could have all the discussions about time complexity trade-offs and data structures and everything. It's a great way for me to show how much I know about these data structures and why I'm coding the way I'm coding. So yeah, it was a fun interview.
Great. Glad you had fun. I will say though that one thing you could do when interviewing for a company is to look up what style of interviews they have. Nitesh, he works at Google. They do interviewing whiteboard style over Google Docs. So, doing a lot of syntax or actual coding. For me, my company cares a little bit more about can you actually implement a solution? We're not a cutting edge tech company like Google is. We're trying to just implement technology to change a pretty old, outdated industry. And so by knowing a little bit more about the company, you can prepare more for their interview style.